Hello, this is Susan Poss again, and I'm looking with you at the section 6.5, which is a summary of various factoring techniques. For those of you who are in 101, you've just finished 6.1, point 2, point 3, and point 4, and point 5 is just a big summary of all of that. If you're in 102, this is a good way to review what you would have already learned in 101. And I've pulled out 3 examples here that all contain fractions, because generally that's a trouble spot for students. So this first one has a couple of things going on. The first thing I notice is that there's a greatest common factor of 1/2, and that was the first factoring technique that you learned back in section 6.1. So I'm going to factor out the common 1/2 and then figure out what goes inside the parentheses. So I need to take this 1 over 162 and divide it by the GCF, excuse me, in order to figure out what goes inside the parentheses. So I wanted to show you all of these steps. When you divide by 1/2, that's the same as multiplying by 2 over 1, if you remember that reciprocal. So this works. The numeric part turns out to be 1 over 81, and then there's the x squared. So I'll go ahead and record that. And then I want to take the negative 150, negative 1 over 50, and divide that by the GCF 1/2. And of course, just as in the previous one, this becomes times 2 over 1. And that gives me negative 1 over 25. And of course, then there's the variable y squared. So now as I'm working along, I'm remembering something called the difference of two squares, and you can see it down here in this next example. This 81 is a perfect square, 25 is a perfect square, 1 and 1 are perfect squares. It's connected in the center by minus, so it fits that word difference. And these two exponents are even exponents. So this fits all the characteristics of the difference of two squares. And the way this factors is it breaks down into 2 parentheses. One contains a positive or a plus in the center, and the other one contains a minus. So taking the square root of 1 over 81 and the square root of x squared, those get split up into each of the 2 parentheses. Then taking the square root of 1 over 25 y squared, you can see that this comes out with a lot of kind of intimidating fractions, but I think the important thing to remind you of here is that this difference of 2 squares goes into a positive and a negative in the parentheses. All right, this next one is pretty much like that previous one. It's, again, the difference of 2 squares. I'm noticing this 81 is a perfect square, 49 is a perfect square, 1 is a perfect square, and the variable has an even exponent. So again, according to my rule for the difference of 2 squares, and this fits all the characteristics, double parentheses, one with a plus in the middle, one with a minus in the middle. Take the square root of 1 over 81 and the square root of x squared. Take the square root of 1 over 49. And again, make sure that you notice a positive and a negative. So that, again, is the difference of 2 squares. And the last one I wanted to remind you about is something called the difference of two cubes. There is also the sum of 2 cubes, which works in exactly the same way. So how do you recognize that? Well, now you see that you've got exponents that are multiples of 3, whereas in the difference of squares, those exponents had to be even. Here, we're working with exponents that are 3s or 6 or 9 or 12, multiples of 3. Also, I'm noticing that 64 is a perfect cube. And I'm also noticing that this 125 is also a perfect cube. All right, so I've got the formula written there. This is one of the ones that you're just going to have to memorize the formula. It breaks down into a binomial factor and a trinomial factor. So you take the cube root of 1 over 64 and you get 1 over 4. You take the cube root of x cubed and you get x. You keep the same sign, so this had a minus, I'm keeping that same minus. You take the cube root of 1 over 125 and you get 1/5. And you take the cube root of y cubed and you get y. All right, so that first step to get the binomial factor is taking a series of cube roots. And you'll notice up here I've got some letters written. The letter S stands for, helps me to remember that whatever the sign started out here in the original difference of cubes, I keep the same sign in that first binomial parentheses. All right, so you can follow the rule up here at the top. Now I take A and square it. So I'm going to take this 1/4 x and square it. And that's what goes into this first position here. Let me clean that up a little bit. Then I multiply the two terms together. That's where this AB is coming from. So I'm taking the 1/4 x and multiplying it by negative 1/5 y, and that's going to give me negative 1 over 20 xy. And notice that it's going to have a reversed sign. And that's what this O stands for, is opposite. So whatever the sign is back here in the original matches in the first binomial factor, and then in the middle here it goes to the opposite. So that's what that letter O stands for, is opposite. And then to get the last term, we go back to the squaring process again. So I'm going to take the negative 1/5 y, I'm going to square that. You see that is going to always be positive. And that AP out there is what represents always positive. So it's that little reminder spells out the word soap. So same sign as the beginning, opposite sign in the middle, and always positive on the end. So I hope that helps you to review the difference of two cubes.